Yeah. So just I'm first time and I'm trying to, get in sync with you. Would you like me to give you one like this to try? Would that be a
Yeah.
good thing to do? Okay.
Yeah.
All right, let's go 4x cubed integral plus 2x minus 1 dx. All right, so go ahead and work through this. If you have questions, please ask and let me know what you come up with.
Okie dokie. Thank you.
How are you doing on this one?
I think I got it.
All right, what's your final answer?
X to the fourth plus x squared minus x plus c.
You got it. Good.
Fire. Awesome.
All right, so number two, we'll look at from your paper there. Uh, you did this when you were learning derivatives, and I call it a rewrite step.
Mm-hmm.
So you're not doing calculus, you're not integrating, you're not taking derivative when you're doing derivatives. You're actually using your college algebra pre-calculus to literally just rewrite what's here. Okay. And I'm going to rewrite it and you tell me if you understand how I wrote it that way.
Yes.
Actually, this one on the
Well,
right is different. Let me
yeah.
leave it like this. Okay. All right. So is that
Yeah.
it? That's okay.
Yeah.
All right. So for the first one, it's the same rule. Same rule. You add one to the exponent. This is where it's really good to write it out, even if you think you know the answer, just so you don't make a mistake. Sometimes when you add subtract numbers, you can easily do something that's wrong.
Mm-hmm.
Now, the next one is more involved here. So the integral of 1 over x dx is the natural log of the absolute value of x plus c. Okay.
Mm-hmm.
And for all the rules, if there's a constant in front, constant integral of some function dx, it's always, let me use k, it's always k times the antiderivative.
Okay.
So if there's a constant in front, you still take the derivative. That's kind of like, I'm sorry, integral. When you,
Mm-hmm.
I probably misspoke there a bunch, but when you're
Okay.
integrating and you know the antiderivative of this just comes with it. So
Okay.
this leads me to sending you over iChat here, table of integrals and derivatives. Okay. So what I'm going to do here is put this in the chat. It's going to serve you for the rest of this course. And if you take another math class, you'll get it as well. But students always ask me, well, which ones do I need to know? The answer is all of them, but you can
Mm-hmm.
check with your teacher, or maybe they've been giving you one. So now this becomes minus 7/2 natural log absolute value of x plus c. All right, now it has to be absolute value. It's only the 1 over x to the minus 1 that this applies to on the right. It's the only one. Doesn't apply to 1 over x squared. Doesn't apply to x. It's just 1 over x. And it doesn't really matter why, frankly. This, you just got to know it to do well in the course.
Mm-hmm.
All right. So now on the left here, you got 4x to the minus 2 over minus 2, which becomes minus 2x to the minus 2. Or maybe depending on how your tests are, it might be rewritten like this.
Okay.
So you have to be comfortable with all the different ways to present your answer.
Okay.
So a lot of students will get the right antiderivative integral, but they will not be able to match it up to
Right to the answer
the answer.
presented.
Oh, and you sent over an answer key. So let me look at that there. Yeah, so your instructor actually used this line for it,
Mm-hmm.
and they're all valid. They're all
Okay.
good.
Huh.
Okay, so Rather than giving you one like this, I think I should do at least one more. I'm gonna skip to 4 next. We'll come back to 5.
Okay.
Um, and then I'll give you one that's kind of a mixed review of these. This one's more like number 1, but because the exponents are fractions, that's what throws off students. So
Mm-hmm.
you have to just say, okay, I still am adding 1 to the exponent, and I'm still dividing by the new exponent. Same thing over here. I'm adding 1, dividing by the new exponent. And notice that I have not tried to simplify the exponents in any of the problems we've done. You will be able to in time, but for now it's good to do this. You do it as long as you get tired of saying, well, I know what -3 + 1 is. I don't need to write that, but
Mm-hmm.
until you do. So this becomes -12x to the 3/2 over 3/2 plus 6x to the -2 over -2 plus c. So then sometimes students are unsure how to proceed from here. Whenever you're dividing by a fraction, you multiply by the reciprocal. So this is really -12 times 2/3, the reciprocal of 3/2.
Mm-hmm.
So that's -8x to the 3/2 -3x to the -2 plus c.
Okay. That one made the most sense.
That's good to hear.
Mm-hmm.
So I'd like to give you one now, kind of a mixture of 2 and 4 to look at, see if you got any questions.
Mm-hmm.
All right. So let's try integral 1 over x to the 1/2 plus 3 over x minus 2 over x to the 3/2. And this is kind of a test question, so sort of.
Okay.
So please ask questions though if you're not sure how to proceed.
All right. Okay. Okay. I don't know if I.
Let me throw a step in here. It would have been good to rewrite the first one like that, the second one as this, and the third one as this.
Okay.
If you didn't do this, you may want to relook at what you've done. But
Yeah. I don't know why I'm so used to putting the pretty much like the x like into a square root, but
that's unfortunately you don't do that when you're in
with
like you always
this.
go to numbers, powers, no roots, and that's where number 3 is. You have to rewrite the roots. It's another kind of another step in these
Okay.
problems.
All right.
Do you want me to continue working it out, or do you want to give it a try from here?
I think I can give it a try from here.
Okay.
Okay. Is it 2 root x plus 3 ln x and then plus 4 over root x plus c?
Now, it is absolute value.
Okay, yeah, oh, right, yes.
That is super critical. It's
Okay.
kind of like putting a plus C, like it's like one of those things where you're like told this is really important, you never know why, and you probably never will unless you want to study a bunch of math. But yeah, and so this is really good. It's really good that you rewrote it like this. Um, this is a good quiz, maybe exam type question you might see,
Mhm.
something like that. So it's excellent. Any questions on what we've done so far? Um,
Do you have like a short but simple answer about the absolute value?
Uh, so 1/x is got a domain restriction where x cannot be 0,
Oh,
and it's part
okay.
of it. Uh, there's also, it's not continuous, and so the
Mhm,
natural log is actually, as you know, it's only defined this way. So
mhm.
you run it. If you don't deal with this one, you end up having to go the other side of it. So it's kind of related to the graphs, but there's more to it than that.
Okay, that
That
makes
you see
more.
you see it in calculus too, but I can't, if I told you now, you would feel like you've been lied to in your math for math your whole life.
Okay, no worries. Thank
Yeah.
you. That even helps enough right there.
Right. The number uh 3. Oh yeah, now I was gonna say. So if I write something like this, like x to the 4/5, you have to know that this is the 5th root of x to the 4th. So
Yeah.
you have to know this mapping. Now I don't remember this one. I generally remember this one, like you did in the previous problem, but what most students don't realize or remember is where the numbers go. So you need some sort of like guide, because when I put the next problem in front of you, the rewrite step, let me do that now. The rewrite step is to write it as a base to a power.
Right.
All right, so you have to be able to, and I'd like you to do that for me. Just the square root of t cubed. Tell me what that is. It's t to what power?
Um, I believe, oh wait, is that 3 halves?
It is, yes. Again, this is just a rewrite step,
Mhm,
no calculus yet. Now it's the same thing you've been doing. You add 1 to the exponent. So the faster you can add 1 to the exponent, like the faster you're like, oh yeah, that's t to the 5 halves. That's
mhm.
better. And then you divide by the new exponent. So the faster you can do that, the better, because then you're going to have less to write, things like that. You're multiplying by the reciprocal.
Mhm. 35, 5.
So it's two, it's ends up being 5 times 2
Oh,
fifths, or
over
this
2. I
becomes,
thought that was a 7 for some reason.
yeah, sorry, my handwriting got poor there.
Oh, no, no, it's
Something
okay.
like that. And this is the last step that, you, like we've been talking about, you get this right, but you realize, oh, it's actually, I got to write the square root of t to the 5th maybe as an
Mhm.
answer for multiple choices like that.
Okay, that makes sense.
Right. So we should do 7 and then 8 and then come back to 5 and 6,
Okay.
because they fall more in line with what we've been doing. So before you learn the product and the quotient rule, you would have something like this, and it would say take a derivative, and you had to know to rewrite it, to use your algebra rules first.
Mhm,
So in this problem, you have to take 2x squared divided by x minus 5 divided by x, and you had to simplify if you could. So on the left here, it's 2x. On the right, it's 5 times 1 over x.
mhm.
Okay, because there is no equivalent to like the product and quotient rule. There is an equivalent to the chain rule in integrals, but you have to be on the lookout for this.
Okay.
Um, me showing you one problem isn't enough, but you have to sort of say, well, do I have a rule for this? And your only rule to this point is x to the n constant and the integral of 1 over x. These are the only ones that we've talked about that are in your toolbox.
Mhm.
So if it's not one of these, well, you can't do it.
Okay.
But this one you can. And I got lazy here. Like you're supposed to write the integral similarly. You're supposed to write the dx. Yeah, but do it for your teacher.
Okay.
Right. So why don't you give this one a try and see if you can find the antiderivative of that.
Okay.
Let me know if you've got a final answer.
I think it's x squared minus 5 ln and then absolute value of x plus c.
You got it. Good. So
Awesome.
whenever I pause, just so you know, like I'm waiting for you. I mean, sometimes I do mute myself and forget, but
Mhm.
just know that sometimes I'm waiting for you to throw something out there. But
Okay.
good job. You're doing great. Like you're you're kind of the exception for some of the students I work with. Like you're answering questions on your own and you're doing a great job. So I like it. First things here, you can take a integral of a letter other than W. I mean, if you really don't like the letter, like I've seen instructors use some Greek letters that students just don't like, you could
Mhm.
change the letter. Like that's allowed. But I wouldn't do it. I would just keep it. I would just learn to use the letter that you're supposed to use, and then keep going. Now here you have to foil. Could you foil this for us, please?
Yeah, is that's why can't I remember what foiling is? Not factoring.
So it's where you multiply the first times the
Oh,
first.
it's rainbow. Okay.
Oh, rainbow. Oh, that's a good one.
Yeah, I don't know
I
why.
haven't heard that in a while.
Yeah. Yeah. Okay, so then
What
5.
what about this side? That's not a rainbow, is it? It's a smiley.
I learned it as I just always would go up with it.
Okay, so you just went higher like that.
Yeah, and then
Uh,
there
and
was
then
one
another.
specific. Yeah, yeah.
Good.
Kind of odd, but
So people often ask me like, "Don't you get tired of doing this?" I'm like, "Well, yeah. I mean, sometimes. I mean, doing the
yeah.
algebra lesson 10 times in a row, but like, I remember stuff like this, and then I'll use it with another student, and it works out. So,
Yeah,
could
it's
you
fun to
rainbow?
learn.
Could you rainbow this for us?
Yeah, of course. 5w to the third, and then a 10w squared minus 6w squared minus 12w.
And you can combine like terms. We
Mhm.
still have not taken an integral. Um,
Yes.
like that. All right, so why don't you try finding the antiderivative of this and integral and just let me know what you come up with.
Okie dokie. Okay. I think I think it is 5w to the fourth over 4, and then plus 4w cubed over 3 minus 6w squared plus c.
All right, good. Now, this is important, but it's unfortunately doesn't really, you're not often able to use this approach. If you take the derivative of this, you should get back to this line.
Okay.
So it's like your check. You often though don't have enough time in these classes to do that. But whenever you find the antiderivative of the integral and you
Mm-hmm.
take its derivative, you should get back to the previous line. And you'll see that you do. You bring the 4 down. That's where this gets confusing when you go back and forth. Bring the 4 down, it cancels that. You get 5w cubed. Bring the 3 down, it cancels the 3, 4w squared. 2 down times 6 is 12 minus 12w. Derivative of a constant is 0.
Yes. Sorry, I'm following.
All right. So whenever you're ready, we can move on to 5.
All right. Yeah,
Okay.
I'm good for 5.
So before we can do 5, I have to give you some new and integral rules. So if like we're building up it's kind of like when you first learn derivatives, we're building up your integral table.
Mm-hmm.
Your e to the x integral, it is the only function whose derivative and integral is itself. The integral of e to the x is itself. The derivative of
Right.
e to the x is itself.
Mm-hmm.
Okay. So that's helpful. Now there's also, when you have the integral of e to the kx, it is itself divided by the k.
Right.
Now this actually falls into what's called the chain rule, which is like the next, I'm sorry, use substitution rule, not chain rule, use substitution rule, which you'll see in the next section,
Okay.
but they're choosing to do it here. Right, so we now have enough information to do this problem. Just because you've been doing such a good job, I'd like you to try doing this yourself. It's just like the two we've got here.
Okay.
See if you can work that out, please. How are you doing on this one?
I think I get it.
Okay, go ahead.
I think I get it. Yeah. Okay. Okay. Sorry, I was double checking. Okay, I think it's e to the power of x plus e squared times x over 2. Like that
Yeah, you
whole,
might say 1/2 e to the
okay.
2x plus.
And then plus c.
Yes. Good, good. Let's do a couple more like this because it can get confusing. The other thing that is like, let's say there's a number in front, the number comes with, number comes with. Let's try a couple more here. Let's say it's the integral of let's go 5e to the x minus 5e to the minus x plus 5e to the 5x.
Mhm.
So I'm intentionally being difficult here, so go slow, but
Mhm.
the only two rules, and I'll copy them down again if you need, but that's the only two rules we've been using for this.
Okay. Would that be a just plus 5ex or e to the x? I mean,
Yeah, the first one's just 5e to the x, yeah,
right. But then that second one with the sign, you would divide that whole thing by -1.
that's right.
So then does that cancel out the negative x?
No, it just
Okay,
cancels out
the beginning
number.
one, right? Okay, that was the only thing that I was a little confused on.
Okay.
And then, ooh, whoa, whoa, whoa. Okay, wait. Would you divide the next one by 5?
Yes.
Okay, okay. For some reason, I wanted to subtract from the 5 first, but okay. Yeah, so then just e to the 5th, and then x. Yeah,
5x, e to the 5x,
e to the
plus c.
5x.
Good. Can
Yes.
you combine any of these?
Mm, maybe.
Yeah, maybe.
I don't really know.
Okay. So the analogy is like when you have like x squared plus 3x plus 1 inside parentheses,
Mhm.
and then you multiply everything by x, so you get x cubed plus 3x
Oh,
squared plus x. You still can't combine anything. Like you
right.
couldn't combine anything here, and you can't combine anything here.
Okay.
Maybe's it's kind of like the engineer's answer to everything. Well, maybe, you know. So, all right. Okay, let's me have you do one more of these. All right, so maybe just try one more here with grouping, and then we'll move on to the next type.
Is it -2e to the negative third power x minus 4e to the 1/2 power x plus c?
Yes. Yes.
These ones make a lot of sense.
Great. Right. Give me just a moment here. So we're gonna get to the problem is they've introduced like use substitution problems in this that they shouldn't have. And
Makes sense.
unfortunately, it makes this more confusing. So like 6, before we can do 6, I have to give you more information. So to do 6, we're going to go back to derivatives. So
Mhm.
you remember sine x, what the derivative of sine x is?
Negative cosine x.
It's just cosine x.
Oh, just
And then,
cosine x.
and
Sure.
then minus sine x minus cosine x. And then
Oh.
hopefully you were shown that this wraps around.
Yes, that's what it
Okay,
is.
great. So the integrals, so this is derivatives,
Mhm.
integrals go the other way.
Okay.
So the integral of sine x is minus cosine x.
Oh.
The integral of cosine x dx is sine x.
Okay.
And normally that's what you start with, but like I said, unfortunately your instructor has introduced a u substitution thing in here. So we
Mhm.
have to modify these a little bit. The integral of sine kx dx is minus cosine kx divided by k plus c.
Huh.
The integral of cosine kx dx is sine kx divided by k plus c. And these are also plus c, I guess I should have.
Okay. Hmm. Sorry, I was taking a picture of that one because I'm gonna add that one to my notes. That makes sense.
Okay.
It's just a little weird.
So now we can do number 6 whenever you're ready. Do that.
I'm ready when you are.
All right. All right. So the first one here is sine of 4 sine 3t. That's this one.
Okay.
So really it should just probably it should just been 4 sine t, but they chose to do it this way. So it's 4, sorry, it's minus 4
Cosine.
cosine 3t divided by 3.
Mm-hmm.
The integral of cosine t is sine t, so it's minus 5 sine t plus c.
Okay. That makes sense.
So like most things in life, math included, it's not that you can't do like any one of these. When you see an example, it's when it's all mixed together. That's where you got to do the practice. So like
Yeah.
one of the things you can do is rewatch the video. And I
Mhm.
tend to pause before doing the problems where you just pause it and then you just rework the problem on your own, tomorrow at some point, or whenever you
Right.
want to study. And
Yeah.
that's a great way to like refresh on
Okay.
this. So okay, let's move on to 9.
Okie dokie.
All right. Is this a typical length homework assignment for you?
Yeah, this is really just like these are the practice ones. I haven't.
'Cause I'm happy if you got what Pearson or WebAssign, we can always do those as well. Just you let me know.
Okay, yeah, I typically will. The only reason I didn't is because I kind of thought that maybe I should try doing like the practice ones with you, and then I can test my knowledge with.
Yeah, absolutely. And one of the nice things about, you get some feedback on the WebAssign, you got the solutions, you got some like
Right.
practice and other problems. I mean, it's a good thing. Okay, so this problem right here, it's formatted differently than the others, but what it really is asking you to do is this. This is what it's asking you to do.
I see.
Okay, so what I'd like you to do is to integrate this and give me your result. If you have questions, please ask. And
Okay. Okay, I think this is right, but I don't really know. But oh wait, no, okay, yeah. Is it 2x cubed plus 9x squared minus 2x plus c?
so take the derivative of this, and you will find that it is not this
Oh my
previous
gosh, no,
line.
it's definitely not that. Okay, hold
All
on.
right,
I
so why
take
don't
it
you
back.
reset? Remember, you add 1, divide by the new exponent.
Oh, that's right. Okay. 4x cubed all over 3.
Okay.
And then plus 9x squared all over 2. Or yeah, 9 over 2x squared.
Well,
And
you're
then
saying it's fine. I'm just writing it slightly different, but yes, that's correct.
okay. And then and then is it negative 2x? Yeah, and then plus c.
Okay, so this is your f of x now.
Okay.
So f prime means derivative. F of x in this case is what's called the antiderivative. You may have heard me saying that, not being sure what I was alluding to.
Mhm.
There's a lot of like overlap. Integral, antiderivative, they're all the same. Okay.
Okay.
Now this is considered an initial value problem. And the reason is because they're giving you an initial value.
Right.
The initial value is used to find C.
Okay.
So in all the previous problems we did, you didn't have to find C. Sometimes you have to find C, and that's the case here. So you have to
Okay.
put 10 in for f of x,
Right.
0 in for x.
And that would give you c.
Yes. Now the mistake here is to think that C is always the number.
Mm-hmm.
It is not always that number. So work it out. Don't
Right.
shortcut it. And this one it is. It's kind of like when you find the slope or the intercept, you have to rewrite now. You have to rewrite
Ah. Okay.
with it. So this is your final answer.
Okay.
So if you don't write this, you're not right. If even if you just do the antiderivative, even if you find C, you have to show the full everything.
Okay. So you can't just leave it at plus c.
That's right.
Okay.
And you'll learn about this maybe in this course. I'm sorry, are you going to take a calculus too?
Um, I'm not supposed to, but I
Okay.
do know that for my major, I think that there's like looking at adding it to the graduation requirements.
Well, geez. Okay. Well,
Yeah.
anyway, I'm not going to give you why this here. This is the
Yeah.
mechanics of this is like what to do.
I should be done with just this, but
Okay. Good.
yeah. Yeah.
All right.
All right.
So 11 is really similar
Okay.
because you are finding the antiderivative, the integral. So I'd like you to try to find the integral antiderivative of this.
Okie dokie.
Let me know when you've got your antiderivative for this one.
Oh, okay, I think I have the antiderivative.
Okay, go ahead.
It would be 8/3 t to the 3/2,
Good. Minus.
and then minus 7t plus c.
Good, and that's your h of t.
Right.
So I'll give you right y. It's fine. So now I want you to find the constant, and it's not 9. You're putting
Right.
4 in for the t here. You have to be able to raise 4 to the 3/2 power. Are you generally allowed to use a calculator in this class?
Yeah.
Okay, so please feel free to use one here, and let me know what you come up with for your value of t. Or c, sorry.
I had to get a calculator. Mm.
It is a fraction, and it's not a pleasant one, but it is a fraction.
Okay, yeah. Is it 7/3?
A little bit bigger than that. So I got, so this is 9 equals 8/3. Now 4 is really going to be 2 squared. Okay, well, let's take a look at that. So minus 28, we're adding 28 to both sides.
Mhm.
So that's your 37 equals 8/3. 2 squared to the 2/3 or 3/2 power becomes 2 to the 8th. I'm sorry, the 2's on the bottom cancel, becomes 2 cubed. It becomes 16/3.
Oh, okay.
And actually, I don't like the answer here. I wrote down y of 4 equals 9. Trying to. So this becomes. This isn't right.
Hmm.
Something's wrong here. This is fine. Recur to minus 7t plus c. So you put the 9 in there, the 4 there, 2 squared, 2 to the power 3 is 8. Oh, that's what it is. It's 64/3. Sorry, that's why this is so messed up. 64/3.
Okay, that makes
37/1. You have to make it over 3. It becomes 111.
Mhm.
And then you subtract and you get 47/3 equals c, like that.
All right, well, then you put that back in there and
All right, so my lessons are 50 minutes. Gonna go ahead and stop